Okay, this section is called internal external division of a line. Really, this is an extension of the work we did on midpoint. Now, when we talk about midpoint, we're talking about splitting a line up in a division of 1 to 1. So that's the ratio. It's half-half ratio of 1 to 1. So the idea here is that what if we wanted to split an interval in a different ratio, say 4 to 5, 8 to 1, 2 to 7? What does it look like? So in this case, we've got an interval xy, and it's got a number of different points in between, and they're all equidistant. So if we look at the ratio of xd, so if we go across to xd, that's been split up into 4 parts. So it's 4 parts to d, and then from d to y is 5 parts. So what we say is d it divides the interval xy in the ratio of 4 to 5. So if we look at b, we go across 2 to b, and then 7 to y. So b divides xy in the ratio of 2 to 7. H would divide the xy in ratio of 8 to 1. So there's 1 there, 8 to x there. Xc to cy would be, well, 3 to 6, which can, again, simplify your ratio to 1 to 2. So as we said, like if looking at the ratio of 5 to 4, that point E divides the line, the inline or the interval in a ratio of 5 to 4, or it's xe to ey, and 1 to 8 is a, and so on. So that's what we talk about when we're doing internal division of a line, splitting at the ratio, putting the ratio of the line or interval into a certain amount of points, and then what's our ratio and where's those points there. So that's internal division. External division is along the same lines, except this time if we consider a interval here, AB, we'd say that x, y, z, w, and v divide that line externally. So what basically you're saying is the point of division is on AB produced or BA produced. So basically, we're going to, in the division, it's going to be extended from AB. So if y divides AB externally in the ratio of 1 to 5. What we're saying is that a to y is in a ratio of y to b. So that ratio there of a to y is 1, but ratio of y to b would be 5. So that means if a to y is 1, b to y is 5, that means there must be 4 parts between a and b, because you've got to do in a ratio of 1 to 5. So what we really say in this case, when we divide externally, we're in a ratio of minus 1 to 5. Depends on which we're looking at our direction, because if we consider b in the positive direction, a is going in the opposite direction, and vice versa. It's all a matter of perception in that case, whether you put a negative there or a negative there, depending on which way you're looking at it as a positive type of situation. But basically, because one's negative, one's positive, the ratios are in an opposite direction. So we can see that ratio of a to y is 1, but y to b is 5, and they're in opposite directions. So if you look at v here, v would divide AB in the ratio of 7 to 3. So AV is 7, so going from A to V, if we take that as the positive, then B to V is and V to B is going in the opposite direction, because we go A to V and V to B. So it's in the minus 3, so it's in the opposite direction. So there's 3 parts there, 7 parts there. So the 4 plus the 3, and then back the 3. So that's where we start to see there. Now, when we do apply a formula to find the points that internally or externally divide a line, we only really need to use one formula, and this is the formula here. So we've got this situation where we've got to use, and it's along the lines of the midpoint formula, but what we've got here is that if we're going to use external division of a line, make m or n negative. As we said, it's only changing around the values and making one negative, one positive, because they're changing direction. So the way when we do this is, if you set up your points that you've got to divide and your ratio, basically your ratio parts will multiply by the opposite there. So I always set it up when I do this formula, notice the n goes with x1 and n goes with y1 here, and m goes with x2 and y2. So that's how I always set up when I'm doing the formula. So let's have a look at some questions and how we're doing this. So firstly, if we've got a point P, it's dividing AB in the ratio of 3 to 1. What that means is the ratio of A to P to P to B is 3 to 1. So B is 1 unit from P and A is 3 units. So when we look at that situation, there's 4 parts between A and B in that case. So if I draw up a line, I've done it both ways here. With the formula, there's the application of the formula, and you get to the point. I like doing it this way. This is really what it's about. There's 4 parts between, if we consider 4 parts between A and B, there's 3 parts to P and 1 part to B. So A to P was 3, P to B was 1. And they're both going to go in the same direction, so that's why you can do that jump. Now, if there's going to be 4 parts, the difference between A and B, 5 to 7, there, is 2. So there's 2 units between the 5 and the 7. If I look at the y coordinates, which I put on the bottom of my line there, there's 2 units between 7 and 9 as well. If I split that into 4, every part is worth a half. So if I'm going to go 3 parts, that'll mean it goes to 6.5 there, and the other half there goes to 7. That makes sense. So 6.5 is the x coordinate, and again I split, it's in two units there, so I split into 4 parts, which means every part is a half. So 7.5, 8, 8.5. So, and there's my y coordinate there that P must be on 8.5. So I get the same point whether I use the formula or do it in splitting it up. I like to split it up. Again, I think this is the essence of what the question's talking about. Sometimes we don't really understand what we're doing with the formula, but the formula works, so you can use that. This time, if we've got the coordinates of R, which divides this interval externally in the ratio of 4 to 3. So what it's saying here is that when I go from X to R, that's 4 units away, and then going back in the opposite direction, R to Y, or Y to R, well, we should say R to Y, is 3 units in the opposite direction because it's divided externally. So there's 4 units that way, 3 units that way, which means it's 1 unit, 1 part between X and Y. Now again, I look at where X and Y, what my numbers are there. So -1 to -3 for the X values means I go -2 if I'm going from X to Y, which means if one part is -2, going from X to R would be another 3 parts, so another 3 lots of -2, which is going to put me at -9. For X to Y with the Y coordinate, I'm going from -4 to -7, which means I'm going -3. I'm going down by 3, which means to go to R, I go another 3 lots of -3. So 4 lots of -3 between X and R, 3 lots of 3 between R and Y going back. So that's where we get the -16. So -9, -16. And there's our point. Again, I've applied the formula using, doesn't matter, I've used the -4 for the first ratio. I could have used -3, it would work out exactly the same. Do it yourself and see if it works out. In question 3 here, this time we want to find the points of trisection. So instead of bisecting a line, we're going to trisect it between 1, -3. So there's our X and Y. I've drawn my line. And -5, 6. So if I look at going from -1 to -5, now that would be 6 units all up. So to go from 1 to -5, it's 6 units there. So, and if we want to look at it, it's -6 because I'm going in the negative direction. So if I'm looking at that, I'm going 2, 2, 2, because 6 divided by the 3, because it's trisected, would be 2. So I'm going down by 2 units each way. So I'm going to go from 1 to -1 to -3 to -5. So that's going to be trisected. And then if I go from -3 to 6, well, there's 9. And this time we're in a positive direction. So it's 9 units there. So I split up into three lots of 3. So I go from -3 to 0, 0 to 3, 3 to 6. What are the points of trisection? So they're the 2 points that will trisect those two. So that would be minus 1, 0 and minus 3, 3. So that would be the 2 points that are going to give it to you. What you want to do if you want to use the formula, you consider a 1 to 2 internal division and then a 2 to 1 internal division as such if you want to do that. I much prefer using the line. I just find I understand where the points are and what's happening with the points much better than if I use a formula. It's up to you, but my personal preference is the line. I think it gives more understanding.